Today we talk about one important topic, obviously related to non-linear space. We discuss today dense set and separable set, and obviously LPB separable or not. We discuss today. Okay, so first we start about dense set. Okay, we have this definition of dense set. First we start about dense set. So right here is subset M of X. M of X obviously a matrix space. Okay, then it's said to be dense in X. Okay, if this one M closer equal to X, we know about some dense set means we take any neighborhood from, that means we take this subset of X, and this one is dense in X means any neighborhood from X intersection M not equal to 5. That means we know about that some Bx are intersection M not equal to 5. Okay, for X belongs to X and R greater than 0. We know about this X, that means this definition of dense set. But now we also discuss in this way, just M closure. We also discuss closure in next, that means in previous class. So we represent this dense set in this way, M closure equal to X. I understand. So we write it in this format. We write it in norm space. Okay, similar way, that means this one is not needed here. A subset M of X. Okay, X being a norm space, a norm space, it's said to be dense in X if something M closure equal to X. And so what happened, that is, okay, that is for X belongs to X, R greater than 0, then mod of X, how this one we represent, we take any ball in this way, mod X are less than such that X, okay, intersection M not equal to 5. Not a problem at all, I think. Okay, then this one is, that means X such that norm X less than R intersection M not equal to 5. Okay, so in this way we discuss dense set in norm space and obviously in matrix space. Okay, so we know, that means we now erase that portion and going to further discussion of next topic, separable set. Okay, so separable set, so X is said to be separable, some X set is said to be separable if it has a countable subset which is dense in X. which is tens in x. Okay, so x has a countable subset which is tens in x. Then we call it x be separable. So not a problem at all. We just known about, that means some countable subset, that means countable numbers of elements. Countable number of elements means, that means this set of elements, obviously some injection with n or bijection with n. Okay, then we're going to discussion about LP separable. Okay, one important topic here related to non-space. LP 1 less than p less than infinity or plus infinity be separable. Okay, so how we handle this one? We write it here. Let m be, we write it proof of that. Let m be the set of all sequence. M be the set of all sequences. Set of all sequences. Okay. Y of the form y equal to, here n1 n2 dot 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 n 0 0 dot dot dot. Okay, where n is any positive integer, where n is any positive integer, and n zeros are rational numbers. Okay, and n's are rational numbers. Okay, then what happened? Then we know about that. That means this m is countable. M be countable. Okay. Then we have to show what? We have to show that then we have to show that we have to show that we have to show that m is tens in LP. Okay, so we then we'll discuss some portion. First, let x equal to chi j belongs to LP be arbitrary. Then for every epsilon greater than 0, there is an n depending on epsilon such that summation j equal to n plus 1 to infinity j whole to the power p less than epsilon to the power p by 2. Okay. Now because on the left we have the remainder of a converging series. Okay. Now that means this one be a remainder of a convergent series. Okay. Okay. Now this one be arbitrary, then there, for every epsilon greater than 0 there is an end such that this one happen. Okay. So next step what we do, since the rational are dense in R, since that means Q closure equal to R, that is the rationals are dense in R. So what happened? Then for each ij there is a rational number, there is a rational nj, okay, or eta j, I think close to it. That means for each j, okay, there is a rational eta j. We write it in this way, eta j close to it. Okay. Then what happened? Then we also discuss about that. Hence we can find a y belongs to M. Okay. Hence we can find a y belongs to M, satisfying what? Satisfying those criteria. Erase our portion, then write it now. Satisfying summation j equal to 1 to n j difference eta j whole to the power p less than epsilon by p, epsilon to the power p, okay, by 2. Then what happened? Just this one. That means since Q closure equal to R, the rational are dense in R. So for each ij, there is a rational eta j close to it. Hence we can find a y belongs to M, satisfying that this one. Okay. Then obviously y equal to this one. this eta j. Okay, now what happened, then it follows that okay, dxy to the power p equal to what, equal to summation j equal to 1 to n xi j eta j to the power p plus this one equal to j equal to n plus 1 to infinity xi j whole to the power p. Okay, then no, we also why we defined then y obviously eta j after then 0 we define here, not needed in this way right here. Okay, so this one happened. Okay, then what happened, then we write it now, we're also getting this one is epsilon to the power p by 2, this one is epsilon to the power p by 2, this one equal to epsilon to the power p. So d of xy less than epsilon. Okay, and obviously then m b dense in LP. Okay, so we also handle this, that means this one, some countable subset which are, that means which are obviously dense in LP, so LPB separable. Okay, LPB, therefore LPB separable. Since M is countable and obviously M be dense in LP, so this one is happen. So today I stop here. If you get this type of video, please subscribe my channel, and if you obviously that means like this video, then gives like, and if you that means have some questions and have any suggestions about it, then obviously that means give some comments. Okay, so I stop here.